So hello dear friends, welcome to my YouTube channel. So we are going to discuss about permutation combination type of questions in this particular video. And if you haven't watched the previous videos, do watch them because in that I have explained you the concepts of, permutation when order is important. So order is important here. And when order is not important, it is the question of combination. Then we had discussed about the conditions of and or. So and means you need to multiply, and whenever or is there, you have to add the situation. Okay, then we had seen what you mean by factorial, and we had seen 0 factorial is basically 1. All right, so all these proofs I have given in the previous video. And then we talked about, which is most important thing, called as principle of counting. So let me reiterate this. So principle of counting, basically what it says, if there are, two cities, like for example A, B, C, three cities, and from A to B you have two ways, and B to C you have only one way to go. So here two and then and is used. So 1, 2 times 1 will be equal to 2. So there will be two ways in which you can commute from A to C, right? So how do you interpret this? Is basically there are two ways, this 1 and 2, isn't it? So you can go from A to B in two ways, either this or this. So I'm saying or, so you add 1 plus 1, 2. And then, so A to C is the complete action. So it is divided into subparts, small action that is from A to B and then B to C. So I'm saying, and then, so multiplication is used. So this is what we had discussed in the principle of counting. Okay, then we had seen some questions as well. Now, today's objective of the class is to do more questions. Okay, and learn the different types of questions. Okay, so let me talk about the first one. So the different types of questions, what we are going to do here. So among that, there will be majorly three types I'll be talking about. Three types. So let's begin. So I'm considering type 1 here. So type 1 stands for your digit problems. Okay, where digits are given. So type 1 belongs to digit problems. Now, what are these digit problems? So let me get into that. First question is, let's suppose we are given with three digits, 5, 6, and 7. All right. And the question says, okay, how many choices or how many, numbers can be made? Three digit numbers can be made. So question is, how many three digit numbers can be made? All right. Out of these three given digits, 5, 6, 7. So what will be our approach over here? So let's understand the approach. So approach should be, first put three dashes because it's a three digit number. Now use the basic principle of counting, which says, in how many ways can I fill the first place, second place, and third place? Okay, so now here comes the concept of, two things. That is, can we have 555? Yes, 555 is a number, isn't it? 555 is a three digit number, right? So from here, the first question that should click in our mind is whether or not repetition is allowed or not. Okay, so if repetition is allowed, okay, and repetition not allowed. Repetition is not allowed. So we'll get into these two conditions. So let's consider the first case where the repetition of the digit is allowed. We're considering this first case. Okay, so this can be filled in how many ways? Three ways. Either I can keep 5, or I can keep 6, or I can keep 7, isn't it? So this can also be filled in three ways. And then since repetition is allowed, the first case, so I can fill them in three ways and then three ways and then the unit digit in three ways. So I'm using and, so I'll just multiply. So basically 3 times 3 is 9, 9 times 3 is 27. So the answer for the first case is 27. Okay, when the repetition of the digit is allowed. Right. So 666 is a three digit number. Similarly, 777 is a three digit number, isn't it? So until and unless mentioned in the question, you always go ahead with these two conditions. Okay, whether repetition is allowed or repetition is not allowed. Now let's consider the second case where the repetition is not allowed. So if repetition is not allowed, then I can have three ways in which I can fill the first place, right? From the left. Always from the left we approach until and unless some given condition is given. I'll let you know how to do that, right? So out of 5, 6, and 7, one digit is done. Okay, then how many digits are there to fill the second place? There are two because repetition is not allowed, isn't it? And then one. So when repetition is not allowed, the answer is only 6 ways. So 6 ways is nothing but 6 numbers I can have, right, when the repetition is not allowed. That means 6 different numbers I can make out of 5, 6, and 7. I hope it is clear to you. Okay, now let's see the next illustration. One more question. So not to worry, I'm discussing all the cases and all these things will be clear to you. Now, second question is, let's suppose now 0 is given to us, 5 is given to us, 6 is given to us, and 7. So 4 digits are given to us and I need to make basically 3-digit number. Okay. So we'll again take two cases. That is basically when repetition is allowed and when repetition is not allowed. Getting it? Yes. Repetition is allowed and repetition is not allowed. So I need to make 3-digit number. Okay, when repetition is allowed, the case one. So 3 dashes you keep. Now mind it. Can I have 0 here? Can we have 0? No. Why? Because if I keep 0 in the 1000 place here on the leftmost side, it will become a 2-digit number, right? It will become a 2-digit number. And I don't need 2-digit number. I need 3-digit number, right? So whenever you have 0 as an option, always eliminate. You cannot keep it in the first place, right? So this can be filled in 3 ways, right? Either 5, 6, or 7. Now, how many digits are there to fill the second place? Here, 0 can come now. Okay, so now 4 digits are there, either 0, 5, 6, 7, because repetition is allowed. Okay, so any of the 4 digits I can fill in the second place. Similarly, any of the 4 digits I could keep in this. So only 0 cannot come in this place. So what is my answer? 3 times 4 times 4. Basic principle of counting, right? So that becomes how much? 16 threes are 48. So answer for the with repetition is 48. Now coming on to the next one, when repetition is not allowed. So again, you'll keep 3 dashes. Okay. Obviously, you cannot have 0 over here because it will become a 2-digit number. So now in how many ways can I fill this? I can fill this in 3 ways. And now repetition is not allowed. Now 0 can be put over here, right? So one number is already done. So now this can also be filled in 3 ways. Why? Because one digit is already filled here in the first place. Okay. Now 0 comes here. So let's suppose 5 is already filled. Now there are 3 digits left, 0, 6, 7, which can be filled in this. Now 2 digits are filled, then this can be filled in 2 ways. Okay, so I hope you're getting this. This is the case for repetition is not allowed. So 3 times 3 is basically 9 times 2 is 18. Getting it? So whenever we are filling, right, what we see is always move from left to right. Always fill these dashes from left to right until and unless, some conditions are given to us. So we'll see that as well when the condition is given and when the condition is not given. Okay, perfect. So now let's move on to the second type of, questions, which is basically alphabetic problems. So now let's get into type 2. Alphabetic problems. Now, what are these alphabetic problems? So before we move on to this, just remember two things. N factorial, when I say, right, it means there are n different things. N factorial. What is the significance of n factorial? We should know. It simply means n different things and different things can be arranged in a straight line. Okay, in a straight line in n factorial ways. In n factorial ways. So let me give you the proof as well. Let's suppose we have two different objects, A and B. Right. So in a line, in how many ways can I keep it? So one is this way, A, B first, or you could have B first. You can arrange B first and A later. So order is important. So two ways are there, right? So two different objects are there. So two ways, two into one. So it becomes 2 factorial, right? Similarly, if you have three, then you will have 6 ways. You can try that thing. You'll get 6 ways. Okay, perfect. Now, coming on to this question where we have basically, let's say, question says, we have this word called as begin, right? Begin. So now, question is how many, right? How many phi different, or let me not put it as different, how many phi alphabetic words can be made, okay, can be made using all these elements, using all these elements. This is what the question is. Getting it? So with begin, BEGIN, how many phi alphabetic words can be made using all these elements? That is what the question is. Okay. So just now I have given you one thumb rule. Okay. That thumb rule is n factorial. Getting it? So the thumb rule is n factorial. N factorial means n different things can be arranged in a straight line in n factorial ways, right? So here, how many different things do we have? 5 different alphabets we have, right? BEGIN. So 5 dashes, 1, 2, 3, 4, 5. So using basic principle of counting, if you'll do, right? So 5 alphabetic words, right? I have to make. So this can be filled in 5 ways, 4 ways, 3 ways, 2 ways, and 1 way. Are you getting it? So here, basically this is equal to 5 factorial. And we already knew that the answer will be 5 factorial because here 5 different alphabets are there and they have to be arranged in a line, isn't it? So there will be 5 factorial ways. Getting it? So here, whenever we get the words, right, whenever it is different, so can be made using all these elements. So that simply means on a straight line, how can I arrange them? BEGIN. Are you getting it? So let's see one more example. Let's suppose I give you the word as equation. Okay. Equation. So here 8 different alphabets are there. 8 different alphabets. And all of these 8 different alphabets can be arranged in how many ways? So 8 factorial is the answer, isn't it? 8 factorial because 8 different alphabets are there and they have to be arranged in a line. So this can be done in 8 factorial word, isn't it? So 8 factorial words total we can have out of this word equation. All right. Now, let's talk about the next case with some repetition is there. Let's suppose the word digit. Okay. So here in this word digit, how many different words can we make? So here the answer would be first is 5 factorial because 1, 2, 3, 4, 5. 5 alphabets are there. And then 2 I's are common, isn't it? 2 I's are common. So you just divide by 2 factorial, whatever things are common, right? So remember that I'm not changing the numerator. Numerator remains as it is. But then we have in the denominator put the common things. Common things with the factorial. Okay, so 2 I's were there and therefore we got this. Now similarly, you could think of this word called as Nitin, isn't it? So this is also same as digit. So here also you will have 5 factorial and then divided by 2 factorial. Okay, why? Because there are 2 I's. 2 things are common and then 2 n's are also there, isn't it? So I have to multiply by 2 factorial. So mind it, numerator is not changing, only denominator is becoming divided by 2 factorial and 2 factorial. Does that make sense? Isn't it? Now, I'm going to tell you the logic behind this. Try to understand. What is the logic here? Right? Why do we divide by the common? isn't it? The common elements. So let's try to understand. Let's suppose when I had digit. Okay. So when I replace this I and I, this I put it over here, and this on the rightmost I, if I put it over here, the word which got made remains same, isn't it? The word remains same. If I swap any of the i's, the word basically remains same. It does not change. Does it change? No, it remains same. So if at all it remains same, can I simply say that when digits are repeating, I have to divide by 2? Because I've counted it twice. DIGIT will remain same. But in the case of begin, right, this is one word. And when I swap this E and I, see here, BIGEN, this is a different word. Are you getting it? That is the reason we divide. I hope I'm making sense over here. Okay. All right. Now let's move on to the next concept. Or we could take one more question. Let's suppose this word mathematics is there. Mathematics. Now, how many different words can be made out of this? Right. So how many alphabets are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 11 factorial. Right. So let me write in the usual notation of 11 factorial divided by how many alphabets are repeating. So 2 M's are there, isn't it? 2 T's are there, right? And then 2 A's are also there. So these are the common things. So we know that whatever is common, we put them in the denominator. So what do we write it as? 2 factorial times 2 factorial times 2 factorial. Are you getting a sense out of it? Yes. So that's the thing. Okay. Now, let me get into the third type of problems where we have certain things clubbed together. Right. The third type. So these are also again alphabetic problems. Alphabetic problems with some condition. As I told you initially, until and unless we move from left to right while filling the dashes, and when we have some conditions, okay, with some conditions. Let's see what are these conditions. Okay, this is what the concept is. So the first thing is, let's consider this word begin. And I'm saying is, how many 5 alphabetic words can be made? Okay, question is, how many 5 alphabetic words can be made or can be made. Instead of that, I should write here can be formed. Okay, so condition 1 is if vowels are together. Okay, this is the first condition. Now see how to solve it. Okay, so how many vowels are there? E and I are the vowels, so they are together. So together means they are acting as one quantity. Now what is left out? B, G, and N. So these are 3 different objects, different things, different alphabets, and this is acting as one, right? So what do we have? 3 plus 1. So total 3 plus 1. So we have basically 4 different things, isn't it? We have 4 different things. Now 4 different things can be arranged in how many ways? 4 factorial. Okay. Now E and I can themselves be arranged in how many ways? That can be arranged in 2 factorial ways. Getting it? So this is my answer. Because E and I can be arranged. These are also, 2 different elements, right? E and I alphabets. So they themselves can be arranged in 2 different ways. That is 2 factorial. And then EI is acting as a whole, which is 1. So BGN. So these 3 plus 1, 4. So 4 different things, isn't it? So 4 factorial multiplied by 2 factorial. So vowels are together. Now the next concept is, let's suppose if I had asked you here, the consonants are together. Okay. The consonants are together. So what do you mean by consonants are together? So what are the consonants? B, G, N are the consonants. Yes or no? Yes. So consonants are BGNN. Okay, these three are together, so they'll be called as one unit. And then we have ENI. So 1, 2, and then total 3. So they themselves can be arranged in 3 factorial ways multiplied by BGN can themselves be arranged in 3 factorial ways. So 3 factorial into 3 factorial, that's my answer. Getting it? So BGN are the consonants, they are together. So they are acting as one quantity or, as a group, that is one thing. And then E and I are two different things. Total is 3. So they can be arranged in 3 factorial ways. And then altogether BGN, they themselves can be arranged in 3 factorial ways. So answer is 3 factorial into 3 factorial. Getting it? So I'm using and word over here, right? EIBGN together and BGN themselves can be arranged in 3 factorial ways. Make sense? Perfect. So now what happens over here is, let's say vowels are not together, the third condition. Let's say vowels are not together. Okay. So we don't have any formula here. There is no direct formula to find if vowels are not together. So what is the key concept over here? What we do basically, we find the total ways, okay, and subtract from together. So this is the answer for not together. I hope you are getting this. Okay. So whenever they ask vowels are not together, consonants are not together. So find the total number of ways and then subtract it from the together. Okay. Total ways minus together. So remember this thing. So I hope you understood the basics of 3 types of problems. And then in the next video, we'll discuss the exam type of questions and real problems. Okay. I hope you liked it. Do share with your friends. Thanks for watching.